Hey guys, my name is Raju. Today we'll talk about binary search and why we actually perform binary search. We'll try to understand why we can't perform linear search. What is the benefit? What is the difference, right? So let's start with the Leetcode problem 704. So here it's given an integer array which is actually sorted in ascending order, and an integer target is actually been given. So the question is that write a function to search target in nums. If target exists, then return is index, otherwise return -1. Here it's written you must write an algorithm with order of log n runtime complexity. So order of log n, what they are talking about? What does it mean by order of log n? It's actually complexity. It If we'll talk about the comparison, if let's suppose if you have given an array, if you just think in a very simple way, if you have given an array, let's suppose array is given something like 3, 5, 1, 8, 9, right? So this array is actually, if we'll just index it, right? So this could be of any order. Let's suppose 0, 1, 2, 3, 4, right? If I wanted to search, let's suppose 1. So what we'll do? We'll try to write a simple for loop and you'll try to search it, right? And that's how it can be done. So let's suppose if I'm trying to search it, so I can just go ahead and I can just use a for loop, and I can just try to say that int I equal to 0. Let me use a different color for that, very quick. So here we are. So what you are trying to do that? We are trying to let's look at the simple snippet here. So that will help you actually understand it. So if you see that we are starting from I equal to 0, right? And we are saying that I is less than n. N is nothing but, this is nothing but the length of the array, and I plus plus. What we are trying to do, we are taking the index at 0 and comparing with x. X is nothing but the given element, is nothing but a kind of target. Okay, it's a target element. So basically, if it is found, then we are trying to return I. If not, then we are saying -1. This is something like linear search. But if we talk about in case of linear search, the complexity is order of n, right? Let's suppose if you have 10,000 element in an array, so in that case, it is going to take more time. Basically, the linear search, how it work? Let's suppose we have x-axis and we have y-axis, right? As soon as our input is getting increased, right, our result, like time, is also going to be increased. So this is something like input. Let's suppose we have 0 to 100 element, and then again we have 100 to 1000 element, and again we have 10,000 element. So if we are here, lying here, so it will take lesser time. If we're here, it will take more time. So with respect to input, the time will get increased. So that is what the linear search. So linear search is actually better if you do not have this given array as unsorted. So for an example, if you see that 3, 5, 1, 8, 9 is actually not sorted. But if we know that array is sorted, right, then we can perform the same operation in order of log n, right? Log n is nothing but, it works on the divide and conquer. Let's suppose if we have given an input n, so we are just dividing by 2. Then again, that n by 2, whatever we are saying that, let's suppose there is array, we are just dividing, this array length is n, we are just saying that this is n by 2, this is n by 2. Again further we are dividing in two parts. Let's suppose here we know that my result lies, so we actually divide this into two part again, so we'll get something like n by 4, and this is n by 4. Then again further n by 8, this will again divide in two parts, so it will be n by 8 and n by 8. So this operation will keep going on. So basically what is happening here, we are saying it's n by 2 plus n by 4 plus n by 8 plus and so on. So if we'll do that, right, I mean it will go till n, like n by n, so which is nothing but 1. So this is nothing but a kind of log n. So this is log n. So that is what we are trying to minimize the time in case if our input given array is sorted, right? So for an example, if we'll try to look at here, we have been given few of the inputs which is actually been sorted, and we are trying to find out the output. Let's try to copy this part and let's try to understand it, how actually it's kind of happening. Yeah, let's try to understand this particular example. All right, let's copy it, right? Okay, let me write it if it is not here. So we can just take a same example over here. So it's minus 103 5912. Okay, and it's asking to search a target called 9, right? Yeah, so that is one. So here is target equal to 9, which we need to search. If we try to index it out, here we'll index 0 1 2 3 4 5, right? So if we're trying to search it, since we know that this is sorted, right? This is lower element, then again 0 is greater, then again this is greater, this is greater. So this is sorted in ascending order, right? If we'll try to apply the linear search, it is if I want to search the target 9, right, we'll be able to get it. But the thing is that it is actually going to take lots of time. And finally, we are going to get this result 4. We are going to return index as a 4. But if you know that given input is sorted, then we can apply binary search. If we look at that, the code for binary search, how we are kind of applying that, we have given a nums, which is array, and we have given a target, right? And if we're trying to apply the binary search over here, so how we are doing that? To apply the binary search, what we are doing? So we are just trying to, first of all, we are saying that there is a low and there is a high. So low is nothing but a starting index and high is nothing but the last index, right? And then we are trying to say that if low is less than or equal to high, in that case we are trying to find out the mid index, and once you'll find that, we're trying to compare that whether the element whatever we have at mid is equal to target. If so, we'll return it. If not, what we are trying to do, we are trying to say that we are checking that if target is greater than nums at mid, right? Means target what we are looking for, it's actually greater. Then in that case, we are trying to shift to the right side. Means low, it is going to be a mid plus 1, else high equal to mid minus 1. Why we are able to perform this particular operation? This particular operation we are able to perform because of it's sorted. Because we know that if it is sorted, then we can move to this our low to mid plus 1 in this particular condition, right? If target is actually greater, means target is going to be in right side if it is actually been sorted in the ascending order. Else it will be in the left side, right? So in that case, high will become mid minus 1. So we are going to search in the first part, correct? So that is how we are deciding that. We are just breaking into the parts basically. So if condition is breaking in one part, else condition is like another part, and then based on that we are trying to search it, and then finally we are going to return a result based on this. Let's try to understand with a simple example. Let's take the same example what we have taken that. Let's suppose our example is given something like -1, and then again we have been given some 0 and 3 5, right? So let me just write this example. So we have -1, we have 0, we have 3, we have 5, we have 9, and then again we have 12, right? Let me try to index particular these things, and then we'll understand that how actually it's kind of working. So it's kind of a dry run, right? That's what we're kind of trying to perform it. So here we have 0 1 2 3 4 5. Let me try to do it here. So what we are trying to do, if you see that our low will become actually 0, right, and high will become nums dot length minus 1. If you look at that, the length is 6, so length minus 1 means it will become something is 5, right? Because the length of this array is 6, so length minus 1 we are doing, which is nothing but 5, right? We find out two things. Now let me go ahead and let's try to look at that. We are having the loop, right? So we are here at this particular location. So we are saying that if 0 is less than or equal to 5, yes, this is true. If it is, what we are doing that, we are checking that if nums at mid, what is a mid? So we are just trying to calculate the mid. So what will become mid here in that case? So mid will become low plus high by 2, and what is the value of low? It's like 0 plus 5 by 2. If you look at that, it's finally 5 by 2 is nothing but 2. So if you see that 2, right, 2 we are just pointing to this index. So we are checking that the target is actually been given 9, right? In that case, target is nothing but 9. So we are trying to say that if nums at mid, right, means nums at 3, 2, right, which is nothing but 3, is equal to target, which is 9. No, it's not. If it is not, what we are trying to do, we are trying to move further, and we are trying to make sure, checking that whether target is greater. Yes, our target, if you look at that, we are searching for 9, which is nothing but greater. If a target is greater, right, this is the case. So in that case, we are trying to move to low to right side. So low will become low mid plus 1. So this low, whatever we have currently, it will become mid plus 1. And what is the value of mid? Which is nothing but 2. So it will become 2 plus 1 is nothing but 3, right? So finally we are going to replace here with 3. So now we are just going to search between 3 and 5. Now let me try to simplify this, and let me write it here. So basically we have the array finally like 9, 5, 9, 12, and we have basically 3, 4, 5. Now we are having low here. Low is nothing but 3, high is nothing but 5. In that case, what we are trying to do, we are trying to find out the mid, right? The first thing is that low is less than or equal to high. Yes, it is. 3 is less than or equal to 5. That's actually we are correct here, right? So condition is correct. Now we are trying to calculate the mid. So mid will become low plus high by 2. So which is nothing but 3 plus 5 by 2 is nothing but 8 by 2 is nothing but 4. So 4 means we are just talking about this particular portion. So this is the one which we are talking about. Now we try to check that if mid, right? So array at 4, we got mid as a 4. So we are saying that, like, let's suppose nums we are using, right? Nums at 4 is equal to target, which is 9. What is the value of nums at 4? If you look at that, nums at 4 is nothing but 9. So 9 is equal to 9. Yes, it is. If it is, then we are trying to return the result itself there. So we are trying to return what? We are trying to return mid. And what is the value of mid? Is nothing but 4. So 4 is the answer here. That is what we are trying to return it, right? Let's try to quickly solve this particular problem in Leetcode. We'll try to understand that how it is kind of happening. That same solution that we have actually been submitted over here in the Leetcode. So if you look at that in the Leetcode, what we are trying to do, same thing, we have been given a nums as an input array, and target is given a number. We are trying to find out we are trying to say that low is equal to 0 and high equal to nums dot length minus 1, and while loop, if condition low is less than equal to high, right? In that case, we are trying to calculate the mid, and mid is nothing but the low plus high by 2. And if whatever the element we have at index mid equal to target, then we are returning the mid, which is nothing but the index. Else if we are trying to say that target is greater than nums at mid, then in that case low we are moving to the mid plus 1, means right side. Else we are just moving this high to left side. If it is not found, then we are saying it's minus 1. Let's try to run it. Yeah, we can see that both the test cases been passed. Okay, so yeah, we can see that both the test cases been passed. And also if we're going to submit this, we are able to submit and able to see the result, right? So it's taking very less time. But if we'll try to solve this problem with the linear search, that can be also solved, but it is going to take too much time. It will not be 0 millisecond or something, and probably there will be restriction to submit it. So like, yeah, you guys can try to submit it. Probably it will not be submitting that because it may say that time limit exceeded or something like that, right? So yeah, thank you guys. Thank you for watching the video. Thank you. Bye bye.